Now, let's find the integration of x squared cosine x dx. Here, as I told you before, you have to ask yourself now which is easier to integrate. So let's say that this is u and this is dv. Now, if u is x squared, so du will be 2x dx. And if dv is cosine x dx, so v will be the integration of cosine, which is sine x. So I have now u, du, and v. And then the integration will be of u times v will be u times v, which is x squared sine x minus the integration of v times du. Then it is x squared sine x minus integration of 2 times integration of x sine x. Now, as you see here, we cannot stop here because we have an integration sign. So we will assume that this is u and this is dv. So let's find now here as the integration of x sine x, since this is u and this is dv. So if u is x, du will be 1 dx. If dv is sine x, so v will be negative cosine. Then, so u times our integration of u dv will be u times v, which is negative x cosine x minus integration of negative cosine x dx. Then negative x cosine x minus. Now, what's the integration of negative cosine?
Sine.
Negative sign. Integration of cosine is sine, of negative cosine is negative cosine. So the integration will be negative x cosine x plus sine x. This is now the integration of x sine x. So that's mean, let's replace it here now as x squared sine x minus 2 times, then I will put the integration of x sine x as negative x cosine x plus sine x plus c. This is here how to find the integration of x squared cosine x. Is it clear? Did you solve it correctly?
Teacher.
Yes, teacher.
Now here, integration of x squared ln x dx. Now, what is this? This is u. Now, for ln, what did you know about ln? Did you know about its integration or its derivation?
It's derivation.
You know its derivation. What is the derivation of ln?
1 over
1 over x.
1 over x. Bravo. So because of that, we say that this is u and this is dv. Then, if u is ln x dx, I told you now. What now? Ask yourself for ln. What did you know for ln? Did you know its integration or its derivation? Lesson 2 and lesson 3 in chapter 6. Did we talk about the integration of ln? or we talk about the derivation of len?
The derivation of len.
So because of that, I will say that this is u, because I can find the integration for you, the derivation of for you. But if I say that this is dv, so I need to find to integrate. يعني an integration by parts mean one I will integrate and one I will find its derivation. So which one it's easier to me to integrate and which one is easier to me to find its derivative? This is the meaning of integration by parts. Then I will say, since len, I know its derivative, but I don't know its integration. So I will say that this is u. Because u, it's the function that I need to integrate, to find its derivative. But if I assume that this is dv, so you need to find v. What is the integration of len?
1 over x.
لا. Integration of len is not 1 over x.
Oh, okay. Yeah.
It is derivation of len is 1 over x. So we don't know anything about it. So I will use its derivation. So if u is len x dx, so du will be 1 over x. And if dv is x squared, so v will be, what is the integration of x squared?
X to the power 3 over 3.
Yes, third x cubic. Now then, so the integration of u dv will be u times v minus integration of v times du. Then this will be x squared. So they are 1 over 3 x cubic len of x minus. Here, what did we have? We have to find the integration of 1 over 3 x squared dx. So let's continue here now as 1 over 3 x cubic len x minus 1 over 3. Then we need now to integrate x squared, which is 1 over 3 x cubic plus c. So 1 over 3 x cubic len of x minus 1 over 9 x cubic plus c. This will be now the final answer. Is it clear?
Yes, teacher.
Yes.
Now, here. X plus 1 squared times len 3x dx. For this one now here, x plus 1 squared len 3x dx. What is u and what is dv?
U is len 3x and dv is x plus 1 squared.
Yes, so this is here u and this is here dv. Then I will say if u is len 3x, so what is the derivative of du here?
1 over 3.
Len 3x What is the derivative of ln u? 1 over u times du over dx. So it is 1 over 3x times its derivative, which is 3. Is it right?
Yes, teacher.
Then, now what is dv?
X plus 1 squared.
Yes, it is x plus 1 squared. So you need now to find. So let's say that. It's just one second, please. So now here, first we have to simplify it as x squared plus 2x plus 1. So this is dv. So we need to find v, which is the integration of x squared third x cubic plus x squared plus x. So this is v. And then we say that it is u times v u times v minus the integration of v times du, which is 1 over x. So I can here say that it is like, just 1 second here. Minus integration of third x cubic plus x squared plus x times 1 over x. For this one here, we can take x as a common factor. So it comes like x times 1 over 3 x squared plus x plus 1 times 1 over x. Then x cancel x. So now we have it as third x cubic plus x squared plus x ln 3x minus integration of third x squared plus x plus 1. It is I need now to find the integration of this part here, which is 1 over 3 times 1 over 3 x cubic plus x squared over 2 plus x plus c. This is now here the integration of x plus 1 squared times then the 3x dx. I want to say which is u and which is dv. After that, I find its derivation for u, the integration for dv, and then I will use my formula of the integration by parts, and then I will substitute u times v minus the integration of v times du.
Teacher,
Yes, Darine.
if I want to multiply the ln3 of x to the 1 over 3x cubic plus x squared plus x,
Yes, you
should
can.
I
You can distribute it.
expand ln3 of x ولا زي ما هي؟
No, don't expand it. Just you can say that it is 1 over 3. Sorry. you can say that it's 1 over 3x cubic ln 3x plus x squared ln 3x plus x ln 3x minus 1 over 9 x cubic plus 1 over 2 x squared plus c plus x plus c. You can, or you can keep it as a common factor.
Okay.
Okay. Do you have any question?
No, teacher.
No, teacher. Now, so the two main techniques for the derivation, for the integration are U substitution and integration by parts. So by now we know about if we have two functions that they are multiplied. Here you have two ways to solve them: U substitution or integration by parts. Now, when we use the U substitution and when we use the integration by parts, always do a U substitution if you can. And if you cannot, use integration by parts. So the priority here for the U substitution, if you can solve the integration by U substitution, do it. If you cannot, go to integration by parts. Now, if you have a function g, and this function is multiplied by the derivation of g, so go to the U substitution. I mean, like if you have x squared plus 1 times 2x. Look at the first function. If this function multiplied by its derivative, I mean, like if you have x squared plus 1 times 2x as an example. If you see that this is my function g, and here you have g prime, its derivative. So if you see that is I have this function and its derivative, you go to U substitution. If there's a relation between these two functions, this is a function and this is its derivative, so go to U substitution. But if you see that there's two functions, there's no relation between them, such as ln and cosine. If I find the derivative of cosine, it's not ln, or the derivative of ln, it's not cosine. Go to the integration by parts. If you have two functions that they are multiplied together, there is no relation between them. Once you need one, you need to integrate, and the other you need to differentiate. Go to the integration by parts. So my strategy is to try to play it out in my mind and try to see which one would work better. Here you have to practice more and more to see. Look at the function. This function, can I integrate by parts or by U substitution? So here, the first thing, look at it. Ask yourself, if this is the function, can I find its derivative? Oh, is the second function its derivative? If yes, this is a U substitution. If no, it will be integration by parts. If you find ln and cosine, what is the integration of cosine? Is it ln? No. Is the integration for ln is cosine? No. So we cannot solve it by U substitution. But if I find ln of x and 1 over x, is the derivative of ln is 1 over x? Yes. So I will use U substitution. If I find cosine and sine as an example, they are two functions, they are multiplied. Ask yourself, is there an derivative and an integration between them? Yes. The derivative of sine is cosine, so I will use U substitution. But if you have cosine and e to the power x, there's no relation between them. So I will use by parts. One of the good rule for the thumb is to try U substitution first. If it is work with you, continue. If it is not, go to the integration by parts. If you cannot guess which one to use, first go to U substitution. If it does not work, go to the integration by parts. Let's have this example here. So now think in your mind. This is x squared, and this is x minus 1. And now ask yourself, if I find the derivative of x squared, the derivative of x squared, and if I assume that this is now u, this part, does it will be du or it will be dv? Does it will be u substitution or integration by parts? Now ask yourself, what is the derivative of x squared? It can be x minus 1 or x, or in other words, if you say that this is u, let's say that this is the complicated one is u. When you find now its derivative, it can be x, it can cancel with x, or no, there's no relation between them. Here we have many parts in math. We have algebra, we have trigonometry, we have logarithmic, we have exponential logarithm, and so on. So for the algebra here, this is an algebraically. For this part here, when you find the derivative of x minus 1, is the answer contain x?
Yes.
Yes, it's contained. So I will say that let's assume that x minus 1 is u. So du will be dx. Then here, integration of u, du, and then here what did we have? We have x squared. For this x squared, I need now to replace it by u. Can I replace it? Yes. X minus 1 is u. So u plus 1 is x. So x squared will be u plus 1 squared. So now here I have it as u plus 1 squared times the integration of u, the square root of u du. Then continue. So it's work with me. Since it's work, so this will be the integration by u substitution. Then I will say this is u squared plus 2u plus 1 times u to the power half du. Then let's distribute it on each part. So I have it now as u to the power half times u squared. I need to add them. They will be u to the power 2.5, which is 5/2, plus 2u to the power 3/2, plus u to the power half du. Then I will find the integration as u to the power 5/2 plus 2/2 over 7/2 plus 2u to the power 3/2 plus 2/2 plus 5/2 plus u to the power half plus 1 over 3/2. So they will be 7 or 2 over 7 u to the power 7 over 2 plus 2 over 5 times 2, which is 4 over 5, u to the power 5 over 2 plus 2 over 3 u to the power 3 over 2. Then we need to replace u as 2 over 7 x minus 1 to the power 7 over 2, 4 over 5 x minus 1 to the power 5 over 2 plus 2 over 3 x minus 1 to the power 3 over 2 plus c. So for this part here, what did you do? You ask yourself, if this is u, can I say that it is du? If I find its derivative, can I replace x with u? Yes. So this will be now a u substitution. U substitution means that I need to find u and du. So as we said before, if this is u, so here we have the integration of u. I'll replace now x squared instead of u as u plus 1 squared. Then we have here this function. We need now to integrate it, but we can multiply them. We simplify it as u squared plus 2u plus 1 times u to the power half. Then I will distribute u to the power half by multiplying it by each term to get this answer here. Then we will continue here by integrated by add 1 over 7 over 2. So you will get this final answer. This is here how to find the integration by u substitution. Is it clear?
Yes, teacher.
Yes.